Huh.
No, there was no sunrise. I was like so awake this morning, and then like right at 8, I was like, I'm gonna fall asleep. That was so bad.
All right. You'll actually have 5 more minutes. I misread the bell schedule. If you don't have a copy of the bell schedule and you'd like a picture of it, you're welcome to come take a picture of mine. I'll leave it up here. Y'all got 5 minutes till you're dismissed, though.
So I'm taking AP this class, bio, and it's all graduation. The 16th. Are you in AP bio? It's on graduation?
I checked the schedule because I was like, 16th.
What time is graduation?
Evening. I mean, it's not fun, but it's in the afternoon.
Yeah, the bio test is at 12.
Yeah.
Oh my god. That's awful.
I almost did bio too. So you sit down and
No, because I was gonna take it, but then I was like, I kind of want to take Spanish, and then I don't know, I'm actually like really scared to take Spanish. AP Spanish, yeah. Because there was like summer work, but I didn't decide I was gonna take it until like 2 weeks ago. So I literally like don't know any Spanish besides like what I have to learn. She's gonna talk more Spanish. All Spanish. But it's Miss Kelly.
Oh, not.
I can't handle her. No, but this one's my advisory, so I'm like a little scared. But no.
Yes.
Really? How many classes do you have? Are you in set? You don't set? Oh my god. Are you in lit? What class?
6.
Yeah, I have it tomorrow and I get out after.
Is that your only class?
I have 3 today and 1 tomorrow. Or all 8.
I was gonna just sit like
How many do you take? What are they?
psych,
I'm scared for Spanish, like actually terrified. I have it right now.
oh, right now.
Yeah.
Was it psych teacher?
Oh, you have the new one? Wait, do you have the 5th? Katie's in that class. So is Carly.
Is it the one that you did?
Yeah, I haven't heard her ever.
She's this year. She replaced me.
She replaced Sue. Oh, he's not teaching? He wasn't. I have feeling that that's worse. No, I took the floor. I didn't see it. It's like, it's just really easy. It's really easy. Like, the whole year,
Oh yeah,
it was
that's the
like,
end of the year.
it's like just a little bit of extra busy work sometimes. It's like,
We started doing that.
I was like, I don't know how many classes
Cal
I
Wood,
have.
so that's not so stressful. The first few weeks.
Didn't do
Usually
anything.
students
I
are
was
really
worried about
stressed
it.
the first couple of weeks of calculus.
Okay.
Since y'all have seen some of it before, it's not as bad.
Yeah.
I did flashcards for a little bit. The one unit I would like actually memorize is the unit like the parts of the brain. I think it's 3. Yeah, I would like memorize that for sure because that comes up a lot, and I memorized that and did really well. But that's all I memorized.
Oh yeah. Oh yeah, some of that. JP's.
Huh?
Where was it? What?
AP Spanish, AP Lit, this one, and Bible. That's awful.
Where you wrong?
That's awful. Why is it on graduation?
LDS.
The testing is the 16th to the 6th to the.
And graduation is 16th. It's at 12. It's not even in the morning.
Well, it's hard to tell people where.
Yeah.
Oh yeah, one.
Oh no, Katie's in my class. And Carly. Carly's gonna have extra time too, so she's gonna be stuck. Yeah. Maybe she should do extra. What if you could pick?
You could pick.
Which ones you do extra time on?
Have a good day. Yes.
I've only borrowed for 1 year, so
Okay.
my English is not good.
Okay, it's no problem. It won't be a problem. Just let me know if you ever need any extra like clarification on what something means. Okay, to know you page.
How did they bar this?
We didn't have that one. Let's sharpen it. So I'm not going to take up the getting to know you handout today, but I do want you to go ahead and have it completed. But I figured if we had a couple people absent or schedule changes or any of that kind of stuff, I didn't want to have to try to collect them multiple times. So just make sure you hang on to that. And for those of you that are close to finished with that, you're welcome to move on to the syllabus and start reading through there. I'm going to give you a few minutes to do all this kind of stuff. Then I'll point out some of the stuff about the syllabus. We'll talk about the binder you need for class. There's 2 websites I need you to sign up /bookmark. So that's one of your handouts. We'll talk about that. I'll share a little bit about myself, and then we'll get into just a tiny bit of the math today. So pretty much follow the order of the agenda that's up on the board. And if you happen to have enough time to actually read all the way through the syllabus, I do ask that you and your parent guardians sign it digitally, but you could at least do your signature. But only do that if you actually have time to read it all in class. Here in a bit, I will be checking out a textbook too. We've got enough textbooks that we can keep classroom set in here, and you can take your textbook home. But that's why I'm like for the most part, you guys are wrapping up those first couple things. So again, the get to know you page, if that's not enough time, just do that sometime between now and Wednesday's class. No big deal. The syllabus. So again, you do need to digitally sign that, but please don't do that until you read the whole thing. One of the very few resources I asked you guys to have for this class is a binder, and the binder is very, very, very little work. But I do ask that you number the assignments and keep it organized. So if you notice on the syllabus, it is numbered number 1 already. It's got a number 1 in the top right. And I will try to do that where I number some of those for you guys, but that doesn't always happen, and some stuff has to be on your own paper. So, but I would say the things students usually ask about from the syllabus would be grades. Grades are made up the same way they should have been for you last year, 60-40. 60% comes from major, which would be your big tests and big quizzes, big quizzes. And most of your quizzes, homework, classwork, all that other stuff goes into minor, which is 40%. We don't do extra credit. We don't do retesting. We do take late work, but it has to be completed, and it has to be turned in by that unit assessment. After the unit assessment, it's too late for even late credit. And those are usually the big things, but for those of you that have had time to read through the syllabus, anything else that jumps out at you that you want clarification on? Okay. Then let's go ahead and move on from that as well. Okay, number 2. So this one I didn't number, just forgot to, but that's okay. It's a good lesson for you guys. So this one right here, websites to sign up for. I've got 2 of them I need you to do. This needs to be number 2 in your binder. The way you know it's number 2 in your binder is because it says it up here. Says it up here, number 2. So all that means is you put a big number 2 in the top right. It's like you're numbering it just like a book. And when you have the binder, it goes behind number 1. And that's it. Easy, very, very easy. 10 seconds a class period worth of work. Okay, so for us, we've got 2 that we're going to use enough that I felt like we need to do this on day 1. So the second big box is Google Classroom. You guys are 5th period, so make sure you use the 5th period code. And go ahead and sign up for that. And then the top one is my personal class website, and you need to bookmark that one. Do you have a pass?
I'm supposed to be in this class. I just printed it out.
Okay. You need to get all those handouts on the front desk. So if you have your Chromebook with you guys, go ahead and bookmark that first page, my class website. I'll talk about that one for just a second. I don't know that you care to bookmark it on your phone, but you could always come back and do that later. But bookmark it on your Chromebooks and sign up for a Google Classroom. I don't use Google Classroom a lot, but it is pretty handy, and I do give you guys the option of turning in your homework that way. So I think most students last year preferred that over turning in hard copies. So. first one should look something like this. It is case sensitive, so uppercase letters have to be uppercase. Lowercase has to be lowercase. So, Google Classroom, you'll have the option of turning in your work, and for rare announcements, just a good way to reach everybody, like snow day type stuff. Otherwise, I don't use Google Classroom too much, but this I use a lot. So this is the one that is where I try to post extra resources, help, pretty much anything and everything. So, as you guys kind of scan down, some of this stuff's not too useful yet, but you can see I keep it organized the same way I will organize Gradebook and how I ask you to organize your binder. So number one is supposed to be the syllabus. So I guess if it wasn't number one and you didn't know where it goes in your binder, you could look it up on here. Number two, websites to sign up for, and the next, you could download a new copy of it if you wanted to. Down here later, some worksheet stuff, solutions, video solutions. We're only going to touch on a few of the book questions today, just a handful, but I've been teaching pre-cal for quite a while, and I'll talk about myself here in just a minute, but I've worked all of these out, and at some point I decided that I just needed to make those as videos. So each one of these is individually linked, so like when I eventually assign the rest of the book work for you, if you need help with number 33, you just click number 33, and it should be like a 1 to 4 minute video of just that question to help you out. So this and solutions to check your work and all that kind of stuff. I put all of that on this one. So students use this quite a bit. That's why I asked that you have it bookmarked. Additionally, on the top, in the top right, here's the agenda. Same agenda I had on the board when you guys came in. So this is good if you just forgot what happened in class, you forgot if there's homework, or you missed class and you only have 5 seconds to see what you missed. It gives you a quick little snapshot of what we did, the order we did, the binder numbers, all of that kind of stuff. And it will have multiple days on here, so you can go back and forth as needed as they get there. And then on the far left, I do record our classes. So it records me up here and records anything I do on this computer screen. And then that will go on this calendar. So class isn't over yet, but like this afternoon, right here, Monday, August 14th, 5th period pre-calculus, there'll be a link there later. And so you could click that and watch class. It's a lot of work for me to do that, but I found that if you struggle with something and you need to hear the explanation multiple times, it's good. And if you're absent, you can watch the video and get everything, all the same information and details that everybody else got. So it's an easy way to stay up to date with class if you have to miss for school business or you're out sick. Okay, anything jumps out at you about the website that you want to ask? You guys been this quiet all day? Yeah, yes ma'am.
Is the website like updated often? Like
I try to update it at least every other day or something. Like what you would notice, like, hold that in, close it. Like it's not 100% updated right now. Like you can see I didn't number our notes that we're going to take in a minute, but you know what those are from the agenda, so I'll come back and do that later. But yeah, I keep it updated quite a bit. But I also try not to share too much. Like all of this stuff is the stuff we get to from the first test, so I kind of just copy and paste it there from previous years, and then when we get to the second unit, I'll copy and paste. So it's not too much work for me. So, but I do try to keep it updated. Okay, so you guys filled out the get to know me thing. I don't really care to share about myself too much, but here's some of the basics. And I also tried to list a couple things that students often find to be interesting, or they tell me is interesting throughout the year, but I just went ahead and put them up on our slide for the first day. So it's going to be my 18th year as a math teacher, if I counted up correctly. Last 4 years I've been teaching this class and also Calculus AB, which I'm very fortunate for because those are my favorites. But I've taught all of those other classes. I'm the department head for the math department. My dad was a math teacher here for a long time, so if you have any older siblings, or maybe if your parents recognize a Mr. Townsend, from Fayetteville High School math teacher, good chance it's probably my dad, not me. But. And I've been a student in Fayetteville schools the whole time, Bates Elementary from K through 6. And then back when I went through school here, junior high used to be 7 through 9. We didn't have middle school back then. And the high school was only 10 through 12. Does anyone know Bates or have heard of Bates? Okay. The thing is, Bates doesn't exist anymore, so that's why you guys haven't heard of it. But where your cafeteria is where Bates Elementary used to be. They bulldozed that and made it part. But there used to be an elementary school there. I've got a bachelor's degree in mathematics and a master's degree in education, both from the University of Arkansas. I've just lived in Northwest Arkansas my whole life. Since I was a student here, some of the teachers that I had are teachers that are still here. So I think that's a list of all the ones that are still around. So you can see if you recognize any of them. You probably don't recognize Mr. Young. He's not a biology teacher anymore. He's an assistant principal. So. I'm going to be turning 40 in September. I've got one dog and my wife Jessica. We've been married almost 7 years. By far my biggest hobby and time waste, way to relax, is playing video games. So that's pretty much every day, even if just for a few minutes. So if you're into video games, I'll talk to you about that at some point this year. But 2 games I've definitely put the most amount of time into would be Dota 2 and Rocket League. And my 2 favorite games would probably be Ocarina of Time and Mario 64. But those games might be too old for you guys now. Has anyone ever played any of those? Which one?
Ocarina of Time.
Ocarina of Time. High school, I was not a great student. I really enjoyed learning things, but I just wasn't big into busy work. So I would often just take a lower grade versus doing busy work. I haven't taken a sick day at school in about 9 years, which means I have 132 sick days saved up. School district doesn't let us save up more than that. And part of that was almost 7 years ago. We got married on a Friday, but I came to school, taught all day, and then we had the ceremony in the evening. So, oops. And about 2 years ago, after about 10 years of not working out, I had kind of just made a plan for myself that I wanted to try to make it a full year of working out every single day. And I did it. I made it every day, whether I was sick or tired or feeling bad or had a lot to do, any of that. But I just wanted to prove to myself that I could. I still do work out quite a bit, but I don't know. I don't on vacations or if I'm feeling bad and I try to take a day off a week or something. I'm not too crazy about it anymore, but it was a big change. And last thing, as far as I know, I've never had COVID. So felt like I had it a couple times, but I always tested negative. So just a couple random things about myself. Okay, do you guys have any questions about the stuff we've talked about thus far? Okay, then let's actually look at some of the first content that we do, which is from section 4.1. So me and Ms. Thomas are the 2 pre-cal teachers, and we have our first quiz set up on the 3rd day of class. So by doing a little bit of this today, even though I'm sure you don't see it this way, it's really to benefit you and to kind of like split it up over more time, so it's not so much at once, and then expect you to be able to produce it on a quiz. I think those of you that did Honors Algebra 2, I think you did some of this at the end of last year, which would be good. And if you didn't, it's okay. Students do just fine without that in the past. But I will say that for us, most students would say our first couple weeks is probably the most stressful for this class. Just because we start with trigonometry, and so pretty much everything is new, unless you saw this at the end of last year in Honors Algebra 2. But that's kind of a new development. Haven't always done that. So let's look at the notes. And I think I said this is number 3 in your binder. Is that correct? Okay, did I already number it as number 3? Okay, great. So when you have a binder, it goes behind number 2, and then that is it. So we're not going to make it all the way through the notes. We're not going to make it all the way through the book assignment, but we're going to do some of each. And then that way, if you feel like it's a struggle, you can start studying that stuff and not get overwhelmed for our first quiz. All right, so in trigonometry, part of what makes this first part difficult is not that any of this is too terribly difficult to do, it's just a lot of information. So when we talk about angles, we all need to be looking at the same place, which is called standard position. So this is a picture of standard position, where you start at the initial side, which is the positive x-axis. And you guys are welcome to elaborate, put more on your notes, circle, highlight your notes, but you do need to put down at least what I put down on your notes. If I was to give a participation grade on notes, which I do occasionally, not a lot, but sometimes, I would expect to see that. The terminal side is going to be the other side. So it just depends on how big. If you were talking about 10 degrees, 10 degrees is not very big, so the terminal side would be close to the initial side. But you always start on the positive x-axis, the initial side, and then the terminal side is the side that swings around depending on how big the angle is. So you can have positive and negative angles. Positive angles are the ones where you measure counterclockwise. So opposite of the clock. And negative angles are the ones that are measured clockwise. So I ask that you at least put down one example of each here. So just using 10 degrees would start off on the positive x-axis and turn 10 degrees up counterclockwise. And then negative 10 degrees is just as much of a turn. It also starts on the initial side, but it would be measured clockwise instead of counterclockwise. So the negative just indicates the direction. But we work with both. All right, for those of you in Honors Algebra 2 last year, do y'all remember if you did any radian stuff at the end of the year? Yes? Okay. All right, so again, I'm going to show you this like you haven't. Just the same thing I would normally show my students. But degrees, let's make this circle centered at the origin. What I want to point out to you is that you know several things about degrees, and if you know one thing about radians, you already can work with radians a little bit. In this class, we do about half in degrees, half in radians, but for those of you that know you're going to pursue a career in math or science, pretty much all higher mathematics is always in radians. So just a fair warning. But if my angle starts here and ends here, how many degrees is that going to be? Okay, if it doesn't turn at all though. Okay, so it could be 0, or it could go all the way around, which is 360. Those are in the same place, so we're going to call those coterminal on the next page. But really, if you know that 360 is all the way around, you can find lots of spots with very little work. If all the way around is 360, halfway around would be what? Okay, and half of that would be 90, and half of that would be 45. And exactly in the middle of 180 and 360, the average of those two would be 270. 90 more than this, 90 less than this. And of course you can keep going, but you could average these two. I'm just pointing out to you that if you know 360 is all the way around, you can divide some of these angles in half and figure out some of the others. Well, same thing with radians. If a radian does not open up at all, we can say it is 0 radians. And if you know how much you have to turn to go all the way around, we can do some of the same stuff we did over here. So with radians, 2 pi is all the way around. 2 pi radians is all the way around. So I said 360 is all the way around, so I divided that in half and got 180. If 2 pi is all the way around, divide that in half. Halfway around would be 1 pi radian. Half of that would be pi over 2. Half of that would be pi over 4. In the middle of 1 and 2 would be 1.5. But we write it as a fraction. So again, using our same logic of knowing 360 is all the way around, cut some of these angles in half, you know a few of them already. If you know 2 pi is all the way around, you can divide it in half, divide it in half, divide it in half. You can figure out some of these other locations before you memorize them. We also do a lot of work with the unit circle, probably the most important thing we do all semester, but unit circle doesn't come up until the second section. And in the unit circle, you'll have to memorize some of these spots. Now, even with the unit circle, there are some spots that we just don't memorize. Like 0 to 360, it's really easy to locate 221 degrees, I mean roughly. But in radians, we don't want to memorize 360 different spots in terms of pi. That's way too much to memorize. So one of the first things we ask you to do is to be able to convert from degrees to radians or radians to degrees. Now, before I show you how to do this, I want to make the connection and let you see this is no different than you would do like in a science class. If you were trying to convert inches into feet, you would multiply by 1 over 12, right? Or divide by 12. And what you're doing is you want the inch units to go away and the feet units to be left over. So you would say that this is 1/3 of a foot. 4 inches is 1/3 of a foot. We're going to do the same thing with these, but it's a different unit conversion. We don't want to use feet and inches. We want to use degrees and radians. So to convert 2 radians, we're going to multiply by pi radians over 180 degrees. Now, how are these two things similar? What do these two things have in common? Okay, but what's that got to do with this? What's the difference between 1 foot and 12 inches? Okay, but size-wise, they're the same, right? So if 1 foot is the same as 12 inches, it's like I'm multiplying by 1. Anything divided by itself is 1. And multiplying by 1 doesn't change the size, it just changes the appearance. Same thing here. 180 degrees is the same as pi radians. So it's like I'm multiplying by 1, which changes the size but doesn't change, or I'm sorry, does not change the size, just changes the appearance. So I'm going to do the first one for you, and in a couple of minutes I'm going to ask you to try it on this one. So you can either straight up memorize this unit conversion like a formula, or for me personally, I know I want the degree units to cancel, so I need to put degrees in the bottom. Multiply your fractions across the top. I can see radians didn't cancel out with anything, so now it's in radians, which is good for me. And I can reduce my fraction. Divide both by 10 and divide both by 6. Looks like 120 degrees is the same thing as 2 pi third radians. I multiplied by pi over 180 and reduced. How this is useful for you guys now is, let's say in a couple classes I tell you to do something with 2 pi over 3 and you're just not as comfortable with 2 pi over 3 because you haven't used radians very long. But if you know 120 is right here, 30 more than 90, if you know where 120 is and then you can do this skill, you know 2 pi over 3 is in the same spot. Just a different way to name the same thing. So it gives you a little bit more information without having to do a ton of work. Okay, and then to go the opposite direction, to go from radians to degrees, we're going to multiply by the same thing, but it's reciprocal. In this case, I want the radian units to cancel out, and I want the degree units to survive. That's how I know to put radians in the denominator. So same thing, let me work this one for you, and then I'm going to give you a minute to do both of these conversions to make sure that you're doing it okay. Okay, so I've got a radian. So I'm going to multiply by 180 degrees over pi radians. You don't have to keep up with the radian units, but it's kind of nice to see that they cancel out. Multiply your fractions across the top and across the bottom. The pi units are also going to cancel and go away. And you're left with a fraction that reduces. A third of a pi is the same thing as 60 degrees. So again, at least temporarily, that should be helpful to you, because if you know about where 60 degrees is and you can use this unit conversion, then you should have a good idea of where pi over 3 is. Same angle, just different unit types. Same size though. Okay, so if you would, take a minute. Do your best without getting a calculator or anything. Try these two. Try to convert from degrees to radians and one from radians to degrees. This should give you a quick little snapshot of if this is something you either remember from last year or you caught on to it and you don't need to review it, or if it's something that you do need to mark down as reviewing for just a minute before next class. Did y'all do this skill specifically last year? Yes? Okay, good deal. Again, I'm just not used to y'all starting this in Algebra 2, so. Okay, so let's see what you got here. So if you've got 50 degrees, you know this changes it from degrees to radians. Note how the degree symbols cancel each other out. That's why it's no longer in degrees. And you end up with 50 pi over 180, but you could divide the numerator and denominator by 10 and reduce it to 5 pi over 18. Okay with that one? And honestly, that's one that we don't even memorize when we get to the unit circle. So if I needed to know how many radians 50 degrees was, I would actually have to do this, even at the end of the year. This would be the only way for me to figure that out. Okay, going the other way, technically this is a unit circle angle, so I actually have this one memorized, but that's okay. Pi radians under 180 degrees. And I know that because I want the radian units to cancel. And I would like the pi units to cancel. Degrees usually don't have pi in them. And you're left with 5 times 180 over 6. And I said don't bother getting a calculator out, so try to do this in steps. How many times does 6 go into 180? 30, good. So really it was 5 times 30. Or 150 degrees. Now, I know at first this is kind of awkward, but over time you should try to see if that makes sense to you. If this is 180 degrees, 150 is a little bit less than that. 150 is almost 180. And 5 pi over 6 is almost 1 pi. 6 pi over 6 would be 1 pi. So 5 pi over 6 is close to pi. 150 degrees is close to 180. So to me, that's reasonable. That seems like those make sense. But ultimately, you have to know these unit conversions to be able to do that. So make sure you memorize those if need be. Okay, any questions y'all would like to ask about that little section? We're going to look at just one more section and then practice a few of these out of the textbook. And I need to check out the books to y'all, so I'll need a few minutes to do that. Okay, then the last part we're going to look at today is a term called coterminal angles. So I mentioned this earlier, I threw the word out, but these are any angles that have the same starting side, same initial side, which is basically everything. Everything starts on the initial side until you're told differently. But also the same terminal side. So they're not the same angle, but they start and end at the same place. So the one that came up earlier, without me even saying anything, is I said, if this angle doesn't open up at all, how many degrees is that? Sorry, I'm hard of hearing. What'd y'all say?
0.
Okay. 0. Now, is 360 and 0 the same angle? Definitely not. If you do a skateboarding trick and you do a 0-degree spin, no one's going to be impressed by that. You do a 360-degree spin, you're going all the way around, right? But these are an example of coterminal. They both start at the initial side and end at the initial side. It's just that 0 doesn't open up at all. 360 opens all the way around. So what we're really doing to go from this one to this one is we're adding a revolution. We're adding a trip around the circle. Add 360. So another one that I have listed, you could also subtract a revolution. 330 degrees and negative 30 degrees are considered coterminal. Negative 30 would be about right here, 30 degrees this direction, and 330 would be almost all the way around. All of this would represent 330. But they both start and end at the same place. That's what we call coterminal angles. That ends up being important in the trick. So I will spare you today and not tell you why yet, but I promise within a week or two you'll see why it's important. Okay, so what would be a quick angle that we could give that is coterminal to 10 degrees?
370.
Okay, 370. Add a quick little revolution. Is there any others? Okay, you could also subtract a revolution, so negative 350. Good. But if you want to add 5 revolutions, I guess it's not wrong. I don't know why anyone would do that extra work, but you could add 2 360s or 3 360s, or subtract 4 360s or subtract 5 360s. So it's just a matter of adding or subtracting revolutions. Your textbook, and I think we do it the same way in your quizzes, we often ask for a positive answer, positive coterminal answer, and a negative coterminal answer, one of each. Okay, so if one was negative 100, what could be a positive coterminal angle to that? 60. So even though negative 460 is coterminal, this question just specifically asks for positive. Just adding a revolution. That's how you land in the same place. Okay, what I'd like y'all to do for just a moment is try these last 3. The first 2 are in degrees, like we talked about, and we're going to go over the last one too, but the last one's in radians, so I want you to think about how you would approach that and see if you have a good guess before I just tell you. Then I'm going to have you start on the couple first book assignments to give me, or book problems, give me time to check out textbooks. And then we'll go over a few of those, and then that will be class for today. You either need to leave your phone or put your name on the board till you bring the pass back. Okay, I'm guessing the first two went hopefully pretty quickly. This one, you could have added 360 to get 420 degrees, but it specifically said negative. So if you subtract a revolution, I'd say the most common answer would be negative 300 degrees. Good? Okay, the next one wants positive and negative. So you could add 360 to get a positive answer. That'd be like 510. Or you could subtract 360, which would give you, is it negative 210? Does that sound right? Okay. So add a revolution, subtract a revolution. Not hard arithmetic, but you have to know what a coterminal angle is, and you have to understand why adding and subtracting a revolution helps you find those. Okay, so that being said, now this guy's in radians. I know this is not degrees because it doesn't have the degree symbol and it doesn't use the degree word. In fact, radians are considered the blank unit. So whether you say radians or you don't say anything, it's assumed to be radians. So does anybody have a guess how to do that or what you think a coterminal angle might be? 11 pi over 4 works. Anybody find a different one? Good. Negative 5 pi over 4 also works. So how are y'all getting those? Because you're not just adding 360 or subtracting 360 because we're not dealing with degrees.
Yeah, we subtract 2 pi.
Very good. You're still adding or subtracting a revolution, but in radians, a revolution is 2 pi. So we do quite a bit of fraction work, especially the first few weeks here. You need to make sure you can multiply, divide, add, and subtract fractions. But 2 pi is the same thing as 8 pi over 4. So if you added a revolution, you could get the answer at 11 pi over 4 that was shared with us. Or you could subtract a revolution. Subtracting 2 pi is the same thing as subtracting 8 pi over 4, common denominator, which is negative pi over 4. But fundamentally, just remember, you're adding and subtracting revolutions. If it's degrees, it's 360. If it's radians, it's 2 pi. Different units. So, okay, that's as far as we're going to get to on the notes today. That way I have time to check out books to you and you have time to try a few of these book questions. So what I need y'all to start on is on your own paper. If you need to borrow a piece of paper from me, just raise your hand, please. You should number assignment 4. So here's the number 4 in the top right. You should copy the assignment down to the top. And then go ahead and start trying the first few questions. And we'll go over some of those together before y'all leave. Does anybody need paper from me? Anybody else? Paper? Now, I will admit a few of the vocab check questions you may not know yet. A question or two of the first ones may seem unfamiliar and you may not know how to do them yet, but that's okay. Just try them. And if you're not sure what to do after 30 seconds or so, save some space on your assignment and move on. Just be ready to pay attention when we go over this. But for textbooks, I will need you guys to come up one at a time. So grab one of the books that I put on your desk. We're going to start off with table 1 here. So if you want to bring yours up, I will quickly get these checked out to you. It's fine, just 1 or 2 at a time. can't do it quicker than that anyway. Okay, Colton?
Cotton. I got Tyler.
Cotton, I'm sorry, I misread it.
That's your long middle name.
Oh.
Either Tyler or Tyler.
Oh, Tyler? Okay. I'm gonna change that on here. Would you prefer, Tyler or Ty?
Either one, doesn't matter.
Thank you.
Am I good?
Yep, you're all good. Okay, Lydia? Related to Harrison?
Yeah, it's my older brother.
It's been a few years, but.
Something like, can I use a restroom?
Yes, so there's a pass hanging here. You either need to leave your phone or put your name on the board until you return. Stella? Okay, thank you. All right, number 4. Nick?
What's the vocabulary check?
It's just the first few questions in there.
Okay.
You'll see when you pull it up. All right, keep on coming. Is it Diana? Is that how you say that? Okay. Thank you. Holland? Thank you. All right, Cole, bring your book up. Okay, Garrett. We need the side one actually. Okay, thank you. Marley? You look familiar. Okay, thanks. Alexander. Alex, bring your book up. You must like math. You're doing AP Stat too?
Yes, sir.
Yep. Okay, Draven. Y'all can keep coming up. As someone's almost done, just keep coming. Again, on the book questions, don't spend more than 30 seconds on one. If you're not sure how to start it, just skip it and move along to one that you sounds familiar. Okay. Check.
Yes.
Go. Now on to Seth. Alright, Lucy. Too far.
Thank you.
Okay, Isabella. Okay, Lena. Lena? Is that how you say it, Lena?
No, it's Lana.
Lana? I'm sorry. You might have to tell me a couple times.
No, you're good.
I assume you're not related to Kane?
I am related to Kane.
Brother?
Yep.
Okay. You have to tell him I said hi sometime.
No, I will.
Okay, Paul?
Yes, sir.
Thank you. Lucia? Okay, thank you. Alright, Sharma. How do you pronounce your first name?
Bridge.
Bridge?
Yeah.
Okay. You have a sister?
Jaya.
Jaya, yeah. It's been a while. Okay, Jacob?
Yes, sir.
Thank you.
Thank you.
Okay, Chase. You go by Chase.
Yes, sir. Can I stop it?
Yes. You need to leave your phone or put your name on the board and take the pass right there. And then when you come back, get your stuff. Olivia? Well, I need your student ID number. There we go. Side, this side. Okay, thank you. Lucas?
Naomi.
Let me do Lucas first. Oh, wait, you can stay up here though. Lucas. gonna say you didn't look like a Lucas to me, but. Thank you. Okay, other Lucas. Thank you. Elise. Thank you. Edith.
Yes.
Thank you. Are you related to Lillian?
I am.
You are? Is that
Yes.
sister?
Yes.
Okay, Tyler. I think I've had several of your siblings.
Probably Spencer and Mason.
Mason and cousin. Christopher.
Yeah, Chris.
Married to Jordan.
Mm-hmm.
I taught at Westford for 4 years, so I had him as a student back then.
Yeah.
Been a while. Caroline? There. Okay, thank you. And Willa? This side one, actually. Okay, thank you. Okay, that looks like that's it. Did I miss anybody? Okay, these are your books to take home and keep home, unless you want to bring it back and forth. I would highly suggest that you guys open up the front cover and put your name in the front cover. That way, if you ever do decide to bring it to school, if you leave it laying in here or in an OPL or something like that, we can actually get it back to you. Sometimes if it's not like that, we can't figure out who it goes to, and then you end up having to pay for the book. So I'd write your name in the front cover. If I was you, I would probably just leave that book at home. Take it home tonight and leave it at home. We have enough for a classroom set, so I will put those on the bookshelf, and I have a sign that I'll put up on days that you need it. So you'll know to grab it on your way in. Okay, let's talk about the vocab check. There's one of those you don't even need to know anymore. There's a couple that we just haven't gotten to yet, so you probably didn't know those either. And then I think question 8 is also a little bit different, so. Let's see how you did. Okay, and for most homework assignments, they are graded on a participation grade, so it's an easy 100%, but you do have to do every question. So like if you don't know the answer to vocab check number 1, or if you don't do the vocab check and then you forget to do it, then you'll get partial credit on your homework, which is easy points given up. Okay, but this one I feel like you should know. Two angles that have the same initial and terminal sides are called what? Okay, coterminal. That's one we've already talked about. Number 2 is kind of an important one, but it doesn't come up in our notes. Does anyone have a guess? Want to guess? Very good. It is a radian. Did you just guess that, or did you find it in the textbook?
I took, or we did trade.
Oh, okay,
It's
good.
a couple weeks ago.
So, by definition, you don't really need to know the definition of a radian to really work with it, but when the radius is equal to the arc length, that is when the angle is 1 radian. We don't really talk about that too much in here, but that's how it's defined. But it's kind of neat to point that out, because if I can estimate this length to kind of look like this length, you could estimate maybe a second one. Like here's maybe 1 radian, here's 2 radians, and the third radian would land about right here. How do I know that?
That's not fine. Because
It's not very good. So pi is 3.14-ish. So 3 radians would be just shy of that, about 3 of those being equal. Okay, number 3. That's the next part of your notes that we didn't get to, but we go ahead and fill this out. If you have 2 positive angles that add up to pi over 2, well, remember pi over 2 is the same thing as 90 degrees. Do you remember in geometry, if 2 angles add up to 90 degrees, what they're called? Very good, complementary. So we use the same terminology in here. And if you have 2 positive angles that add up to 180 degrees, which is the same thing as pi radians, we call those supplementary. So same geometry terms, but we're just extending degrees to also radians now. Okay, number 4 we didn't talk about, but I think you can make an educated guess here. The angle measure that is the equivalent to a rotation of 1 over 360 of a complete revolution about an angle's vertex is 1 what? 1 what? Degree. If you go 1 360th around the circle, that is a degree. And then number 5 is something that we used to make students do in this first section, but we don't make y'all do this now. We'll probably do it at the end of the semester. So number 5 you can cross off the list. I don't expect you to have that one done, even for full credit. Okay, after that, now normally what I would do is ask for your questions. You guys need to have tried them, checked your answer. I guess if it was homework, you could watch the video on the website, but for right now, we're in class and you're not had any time to do that. But number 8 gives you an angle that looks like this. And it wants you to estimate that. Lucas, you need to put your phone up, please. Okay, so any suggestions about how we could do that? Okay, what if so the question wants to know in radians, how many degrees would you estimate this to be?
315.
Okay, so this is 90. Halfway around gets us to 180. To go straight down, that's what? 270. It's 90 more than 180. And so a little bit more than that, you're guessing about 315, is that what you said? All right, so that makes sense. Estimate with degrees because you're more comfortable with degrees. Do we have a way to change degrees into radians? Yes, so that would be what you would probably want to do early in the year. Now, with those numbers, I don't know, you probably want a calculator, but you don't need to go get a calculator just for that. So 115 divided by 360 times pi. So as a decimal, it's about 2 point. Oh, what is wrong with my work? I have a mistake here. I did this earlier too, so that kind of points out to you that
360 instead of 180.
right, pi and 360 aren't equal. I'm changing the size of this. Pi is the same thing as 180. That's a big difference. So that comes out to be about 5 pi over 4, or exactly 5 pi over 4 if you want it in terms of pi. This said round to the nearest 1/2 radian though, so it's about 5.5. I hesitated because I know where pi is, and it's 3.14. So I was about to say my answer was 2, which it wouldn't even be halfway around. So I knew something was wrong. That number didn't make sense. So I don't suspect many people thought to try that at first, but it's good because it kind of shows you if you can estimate degrees, which is a little more comfortable, and if you start to pick up some of these other skills, you know, other than just getting a question or two right on the quiz or test, it allows you to be a little creative and kind of work your way into some of those other ones. Okay, after that, I think is number 11. Is that correct? Okay, so 11 has 2 parts. It wants you to say what quadrant you think pi over 4 is in, and negative 5 pi over 4. So same quadrants. You do need to know the quadrant numbers. Okay, and so what quadrant do you think pi over 4 is going to be in? Huh? 1? Okay. I can hear y'all, I just can't interpret what you're saying very well. I agree. So what you could do, you got 2 options on how to figure this out if you got stuck on this one. Either you can know all the way to, well, all the way around is 2 pi, so halfway around is pi. So if I divide this angle into 4 equal pieces, the first piece is about right here, 1 pi over 4. Second piece is here, 2 pi over 4, but that reduces. Add that piece again, right here is about 3 pi over 4. Add that piece again, you get 4 pi over 4. But that reduces to 1 pi. So that's enough to estimate you're in quadrant 1. Or, just like we talked about earlier, if you want to change this to degrees, which you're supposed to know how to do anyway, pi over 4 is the same as 45 degrees, and that might make it easier for you to know it's quadrant 1. Just an option. Okay, what about negative 5 pi over 4? What does the negative do?
Makes it go clockwise.
It makes it what?
Go clockwise.
Okay, clockwise. So if you know how big 1 pi over 4 is, here's negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4. Quadrant 2. Or you could convert this to degrees. And then if you don't know what quadrant negative 225 lands in, because it's negative, you could find a coterminal angle and figure out that it is in the same spot as 135. So unintentionally, we're starting to see why you might need to be able to find coterminal, why you might want to switch from degrees to radians or radians to degrees. Good skills to have. Okay, let's look at one more together, and then I honestly don't know the bell schedule right now, so. Oh yeah, I've got plenty of time. Okay, let's look at one more together, and then I'll ask that you try to do a couple more before you're done. So I think that is question 15. That's what's next? Okay. Oh no, I'm sorry, 13. 13's next. Okay, sketch pi over 3 and sketch negative 2 pi over 3. Okay, well, if you converted this to degrees, which I'm not going to give you time to do, I will tell you that this is about 60 degrees, or not about, it is exactly 60 degrees. And 60 degrees is going to land in which quadrant? Right? Should be about 2/3 of quadrant 1. So if that helps you, then convert it. The other thing you can do, to me that's too much work. I'm too lazy for that. But I'm a little bit more comfortable with radians. I know halfway around is pi. So if I divide this pi radians into 3 equal parts, here's one piece, second piece, third piece. So here's where the first pi over 3 is. To me, that's quicker than converting them. But. Okay, and then if I did the same thing but negative, if I know this is about a pi third, It's 60 degrees in the negative direction. If I added that again, this gets me to negative 220, which is about negative 2 of these, negative 2 pi thirds. And so there's a sketch. This angle starts on the initial side. It turns this direction this much to get there. Okay, so I know the next couple are about giving a positive coterminal angle, so we have that in the notes. So try it. I think it's number 15. Have you guys used the math textbook in the last couple of years? You've not? Okay. Do you guys know that the odd answers are in the back of the book? Okay, if you don't know that, or even if you do, so when you are at question 15, that's an odd question, what I would do is flip to the back. You have to find chapter 4, section 1, and it will show you what the answer is so that you know you did it correctly, or if you need to ask for some help. And I will come around here in just a minute. But it's a quick way to check your work. For even answers, it's not going to have the even answers in the back, or if you needed more help on it and it was outside of class, that's when I would ask you guys to go to the website I asked you to bookmark and click on the one you need help with. And again, this is better for outside of class. Inside of class, I don't really want you to do that. Most of the videos are me, but this one was already made up by the textbook company, so I just didn't change it. But 3-minute, 30-second video, and they will show you how to do question 15. That's what you're struggling with. All right, so to finish up today, I'd like you, I'm not going to ask that you do any more of this book assignment for homework, but I would like you to try some more of the questions while you're here, because you guys still have about 13 minutes, and all of this is going to be assigned to you. The rest of it's going to be assigned to you next class. So the more of it you get done today, the easier next class will be. So go ahead and try that. But if you see one, like we haven't talked about question 17 yet, so if you think you know how to do it, try it, check your answer. If you got it right, that's great. More power to you. But if you're not sure how to start it, just be quick to skip it. Skip it, go to 19, say it's the same type, skip it, 25. We've talked about those, so you probably have a good chance at 25. So just be quick to skip along, because we haven't talked about all of it yet. Try to get as much done as you can, please. You may. You either need to leave your phone or put your name on the board, take the pass, and then take your phone back or take your name off the board when you come back. Okay, I think that should be the last thing I need to instruct you on the board. If I see a common question, I might interrupt you and work it out on the screen while we're here. But you guys are welcome to check, work together quietly with your neighbors if you'd like to. And if you have something that I can help with that you know you're going to need to ask about, just call me over and come around, please. That's degrees, minutes, and seconds. It's something we're looking at check. But when we do, like, latitude, longitude, within degrees, minutes, and seconds. So about boat, plane navigation, boat navigation, maybe degrees, minutes, and seconds instead of just degrees. I'll tell you how to convert that later. And we'll just have to test it later. Don't worry about it. Again, there's several of these things that we just didn't have time to get to. It's only day one. I only ask that you guys start on this so that if you feel like these first few examples are really tough, you didn't learn this last year, you don't remember it from last year, if need be, you can spend a few minutes outside of class and get caught up with everybody else and not get overwhelmed. So. Hope you don't need any space. Very brave. Think I can help with you? Pretty good. Yeah, so radians are usually in terms of pi, but they don't have to be. So where would pi radians be? Like, show me on a circle where would pi radians be? Okay, so directly to the right is where you started, so that's 0. If 2 pi is all the way around, halfway around is where 1 pi is. So 1 pi radians all the way to the left. So what is pi as a decimal though? Okay, so if you want to know where 4 is, and you know 3.14 is right here, it's going to be a little bit more different. So just sketch it like it's in front of you. Hello? Yes. Hey. I do. Okay. Let her know. Holland. You need to go move your car. You're blocking in some coaches. Yeah, you probably need to take your stuff with you too. I don't think you can be back before the end of class. Exactly, and I can estimate this. Most of the time, radians are in terms of pi, but we don't have to. guys are down to about 3 minutes. Again, you don't have to work ahead on this assignment, but for your own sake, if you feel like you're struggling with some of these first ones, and we got one more class to work on that, we'll also do a practice quiz next class. Do yourself a favor and look it over for 10, 15, 20 minutes so that you can not feel like you're starting behind everybody else. These books are yours. Make sure you take yours with you. If you leave it, it may get lost.